Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving inequalities. So inequalities are like equations, except instead of an equal sign, they have an inequality sign. So like greater than or less than or whatever. So you solve inequalities the same way as for equations. So you undo what's been done to the pronumeral in the opposite order to BIDMAS, but there's just one difference. When you're multiplying or dividing each side of the inequality by a negative, you must reverse the sign. I'll show you what I mean. So 30 minus 7x equals 2. So what we're going to do is subtract 30 from both sides, just like we do for an equation. We have negative 7x is greater than or equal to 2 minus 30. Now, in order to get x by itself here, I need to divide each side by negative 7. So this blue writing up here is saying when you need to divide each side by a negative, you reverse the inequality. So I get x on the left-hand side, negative 28 divided negative 7 is positive 4, but I need to reverse the inequality. X is less than or equal to negative 4. All right, let's try this one. We have x on both sides of the equation, so your first step is to subtract the pronumeral with the lowest coefficient. So this one here has a coefficient of negative 1, lower coefficient. I'm going to subtract negative x from both sides, which is the same as adding x to both sides. So if I add x to both sides, I end up with 10 is greater than 3x plus 22. Subtract 22 from both sides, I get negative 12 is greater than 3x. I'm now going to divide each side by 3. So 4 is greater than x is exactly the same as writing x is less than negative 4. So the thing is, each of these inequalities has infinitely many solutions. A solution is just a value you can substitute for x to make this a true statement. So for this, I could substitute x for 4, or I could substitute x for 3, negative 2. There are infinitely many values. Similarly for here, infinitely many values. So we display our solutions on a number line like this. So how do we draw that? Well, for x equals 4, we'll just put 4 in the center of the number line. Of course, numbers get larger as you go to the right. So for x is less than or equal to negative 4, so I want all the values less than 4, so I'm going to draw a line going this way. Anything less than 4 here is a solution. Now, this blue writing here says when it includes the value, so when it's a greater than or equal to or a less than or equal to, you shade in the circle. So here I've got x is less than or equal to negative 4. So that shows us all the solutions that x can take, all the values x can take, and it shows that we include the value 4 because it's shaded in. On the other hand, for x is less than negative 4, so again we'll put negative 4 in the center of our number line. Numbers get larger as you go to the right, they get smaller as you go to the left. So I want to again point less than negative 4. But this time I have an open circle because I'm not including that value. X equals negative 4 is not a solution to this inequality because it would mean I'd have 14 is greater than 14, which is not true. So negative 4 is not a possible value for x, but anything less than that is. We have arrows here because the numbers can go on forever. There are infinitely many solutions. All right, let's now look at a few harder inequalities. So here we have kind of a nested inequality. We kind of have two inequalities in one. So read this as x minus 2 over 6 is between and including negative 3 and 3. So we'll just follow the same sort of process. We're going to multiply everything here by 6. So I get negative 18 is less than or equal to x minus 2 is less than or equal to 18. X minus 2 is between negative 18 and 18. So now I'm going to simply add 2 to everything. So negative 18 plus 2 and then 18 plus 2. So the values that x can take is anything between including negative 16 and 20. So what would that look like on a number line? So we can just draw it nice and simply between negative 16 and 20. Because it includes both those values, I do a shaded circle. This is the set of all values that x can take. Once again, there are infinitely many such values. All right, let's look at this one that involves a squared term. So x squared minus 1 is greater than 8. So we're going to start by adding 1 to both sides. So I will get x squared is greater than 9. So if x squared is greater than 9, what does that say about x? Well, we can square root both sides and get x is greater than 3, but that's only part of the story. If x squared is greater than 9, x could be greater than 3, but it could also be less than negative 3. Remember, something like negative 4 squared is 16. That's greater than 9. So any value greater than 3 or less than negative 3 will work. When you've got squared terms in inequalities, you have to take account for positive and negative solutions. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.